Alright guys, welcome to the video. Today it's going to be a little bit different of a video. Usually I post videos of projects or things I've done once they're done. But this project I'm looking for some input on before I start. If anybody has some good ideas, just let me know in the comments because I'm looking for some advice or thoughts or feedback before I start this project. Because it's going to be a long and possibly expensive process, so I want to make sure I get it all right before I begin and have to start over halfway through. So what you see here is my Traxxas Summit 6x6. It's pretty much just a normal Traxxas Summit with an extra back half added on, as you can see. So it has 6 40 series mudslingers, which I've cut the treads off, which makes for tons of grip, but I'm actually looking to make it have more traction. So what my idea is to 3D print a set of tracks for it, and over the tire tracks for it, I guess I should say, for the back 2 axles. I'll show you a picture of kind of what I'm talking about later on in the video, but I have a 3D printer, so I was thinking of individually printing track pieces and then pinning them together. So this is just going to be the little intro. We'll go to my computer later and I'll show you my design, but this is the first prototype piece I have. So this footprint here just goes over the tire. It's an extra width. It's going to go like this. Well, the tracks will go all the way like that, and then under and over. So the footprint will be like that. So yeah, I've got some of the dimensions right already. I mean, it's pretty snug with a little bit of play here on the tire. So this is, I just thought I'd do this at the beginning of the video, just give an overall picture of what I'm aiming for and hoping for. So yeah, over the tire tracks, a bunch of these printed pieces put together and then put over the tires, so the whole back half will have tracks. The front will obviously be normal steering, kind of like a half track unit, I guess. So I just thought I'd give a little overview before we go into my computer. Next, I'll show you the design in Fusion 360. If anybody has some feedback, I'd love to hear it. And then after that, we will go to Kira, which is a slicer for 3D printing. And if you're a 3D printing genius, I'd love to hear some feedback on some potential settings. I did some rough calculations. I think I'll need 18 of these pieces per track. So that's 34. And the weight is about 80 grams each, according to the slicer. So long story short, it's going to be about 3 rolls of filament, probably costing upwards of 90 bucks. So I just want some feedback before I begin and waste a bunch of money and a ton of printing time. So if you're a remote control genius or a engineer or a 3D printing genius, or you've done this before, or you just like giving feedback on other people's ideas, keep watching and we'll go over some of the details. And yeah, anything you want to say, just leave it in the comments. Okay, so earlier when I was talking about my tracks, I said these are over the tire tracks. This is what I was talking about. Like, this is a perfect example. The back 2 wheels will just be covered in a track here. Yep, just like this. You see them lots on skid steers. So I won't take my tires off and have a dedicated sprocket or whatever turning the tracks like on a tank or whatever. They're just going to be something I can slip over my existing tires, and just the friction of the tire on the track will drive it. So that is what I was talking about when I said over the tire tracks. That's what gave me the idea. Yep. So now you get a general picture of what the overall project is going to be about. Okay guys, so here we are in Fusion 360. I'm just going to go over the design, my kind of thought process for it. Yeah, if you don't know, if you just know about 3D printing and you don't know about remote control trucks or whatever, it's fine. Each stage I'll kind of try and explain as I go along so everybody can kind of get an idea. So this is different from the one that I showed earlier in the video. The triangle side support pieces were brought in a little bit. They used to go all the way to here and here, I think, which I think will be too wide for when it's turning around the tire. So I brought those in a little bit, and I made this hole smaller. Right now, the thickness of the track is 8 millimeters, and the hole here is just over 3, I believe. There, 3.15. So that's just kind of allowing for shrinkage. I wanted it to be, originally I had it 4 millimeters out of 8 millimeter track, so a 50% hole gap, I guess, which I don't think is the smartest. I plan on using nails for each side here. Like this tongue part will fit in this groove part of the next track ahead of it, obviously. And I plan on just putting nails in, like two nails total, one from each side, meeting in the middle, so approximately half of the track length long nails. So then the points will just meet up in here, which is fine. I was going to use screws so you could remove them and assemble them easier, but I think nails have a better shearing force, and I think that's what it'll be experiencing. So yeah, I haven't found any nails I want to use. When I do, I might recess, like measure the head width and then the head thickness and recess it so it is sitting flush. And then I think I'll just super glue the nails in. I haven't quite got that far. So that's something I'll probably have to change yet. I think using nails is better than using screws. But like I said, I'm open for feedback on anything. So yeah, the tire is, I can't even remember how wide, but goes to here. And then I have a little bit extra width on each side just for footprint. More traction, more I don't know, more stuff touching the ground. I checked, and the extra overhang isn't going to hit any of my suspension parts, so that's good. I have a slight, well, the tire portion, the tread goes here, and the sidewalls bulge out a bit, so I do have a slight angle here. I kind of just arbitrarily picked this angle here. I didn't want them going quite to the end. Seems like a lot of material. These pieces just keep the track on the tire. They will experience sideways forces, I think. So I think this should be good enough for strength. I think these side pieces will be all right. So that's the first thing. The next thing I want some feedback on is, the bottom. Right now, this is what the bottom looks like. It's smooth except for these, half cylinder grooves cut in it, which the diameter is 4 millimeters. So I got that idea from a Thingiverse user, Ogre here. I was already looking on Thingiverse for various tracks or tread designs or whatever. I came across this. His is actually quite similar. It's got a tab here, whatever. But he he designed out a half cylindrical spot, and then he used this rubber string and glued it in for extra grip pads. And I actually think that's a pretty good idea. So he has kind of thinner or shorter tracks, I guess. Mine are longer. So I designed in two of these half cylinder grooves. So I think that's a good idea. I'm not sure if I should add anything else to the bottom. maybe more grooves just to leave empty in case the rubber wears out quick. Like maybe another groove, or shift these up and add 2 more grooves for a total of 4. And I could glue in 2 rubber pieces and leave 2 gaps, maybe like tread, and then if the rubber wears out quick I can replace it. I'm not sure. Or maybe making like a design on the bottom or something. Haven't really determined that yet. The only thing is I plan on printing these with the bottom being on the bottom of the print plate. So I don't want to do, well, anything coming to like points or whatever, because I want it to have a solid base when it's printing, because that's, oh well, I think that'll be more successful. So that's the bottom. If you have any good ideas for that, just let me know. That's mostly the things I wanted to talk about. The rest of it's kind of self-explanatory. Right now these sidewall pieces go up to about the rim, so it should be rubber contacting pretty much the whole track piece, which I think will lead to grip. So next I drew a little, well, just a quick sketch. My wheelbase is 230 millimeters. My tires are approximately 180 millimeters each. So I'm not super good at Fusion 360. I just did a circular arrangement. So these aren't quite touching. There's a little bit gap. So, and here I just drew these lines and they overshoot a bit. So I think when the gaps fill in and the overshoot is left, there'll still be a little bit of room. So I'm not sure. Right now this is 18 pieces. I'm not sure if I should just leave it as 18 pieces and there might be a little bit of slack. These tires, like it's rubber tires and they have foam inside. So the foam kind of provides some back pressure or out pressure, I guess. I don't have any sort of tensioner design. I'm not sure if that's, well, it's easier, that's for sure, but I think I'm just relying on the foam and the rubber wheel construction to provide tension on these tracks and the weight of the vehicle, I guess. So I might just print 18 pieces off, do a rough connection, see how they come together, and design possibly an adjustment tension, maybe a special track piece, a shorter one. 58 millimeters is the distance center to center here. So they'll be pivoting. I think I did this calculation right. Here to here is 58 millimeters, which is center to center. And that's how I think it'll go around the tire. If I did that thinking wrong, just let me know. So yeah, this is the overall design. Not sure on a tension piece. If I do, well, I'll show that. I think also here we have 1, 2, 3, 4, 5, 6 kind of contact points on each tire. So the tire will kind of squish into a, well, 10, I guess only 5 pieces, because this part will be in open air. There'll be 6 contact points on each tire. I think that should be enough traction, just the rubber on the track. I think that should be enough tension to keep it going. So that's my idea, at least. So that's the plan, that's the design. This is the kind of overall construction, how it's going to be. Oh, and one other thing, these 2 tires move independently. They each have independent suspension. So when this tire is fully down and this tire is fully up, I think the tracks will act like limiting straps. So that should also kind of, like, if you hit a bump, this tire will go up first, this tire will go up second. I think just the overall design will kind of lead to traction, or tire to tread traction at least. What else was I going to say? Oh yeah, and the tread design, like each point will kind of be experiencing tension forces, so that's why I wanted there to be nails, because they'll kind of be trying to pull apart from each other. I don't think it'll be too extreme, but I guess we'll find out. So that's where this, I guess, thickness between the inner hole and the outer radius comes into play. I want that to be strong enough that it doesn't just tear apart. So I hope that's a good design. There is 18 pieces on each track that will distribute the force, but yeah, these do move independently. If it becomes a problem, I might design a piece to link the two suspension arms together, and then they'll move, each tire will move together on each side, but that's further down the line. So, okay, so now we're going to go to Kira. I exported, I believe it is this design, my most recent one, to the slicer. So this is how it looks sitting on my build plate. I only have one. I think I can print 3 crosswise, but first things first, I plan on printing this in PETG. I've had lots of success with PETG. It sticks to my bed nice, it prints nice, it's quite strong. So yeah, I think, and it's semi-cheap compared to more exotic filaments like nylon or polycarb or whatever. I don't really want to use PLA. I don't think it's going to be strong enough, and I haven't had much success printing ABS. So I think we're going to go with PETG, which is a pretty strong filament, and it's got some flex to it, which I think will be beneficial. So I think I'll do layer height of 0.3, just because that cuts down on the time a little bit. If it's too much and isn't working out for some of these smaller holes or whatever, I can always turn that down. Wall thickness versus infill is something I'm curious to hear everybody's opinion on. If you don't know what that means, the walls, let's get to a good layer here. So here the walls are the cylindrical part, so the 3D printer will go around, print 4 walls, and then start doing a grid pattern, which is called infill. So I've heard that, well, infill and walls both contribute to strength. Right now I have the wall thickness set to 2 millimeters, so I'll do 5 wall lines because I have a 0.4 millimeter nozzle. So it'll go around 5 times, and then it'll start doing an infill. So if I change that to 6, the overall weight goes up by 2 grams, and it kind of keeps going like that. So I think I've just determined I'm going to do 5 walls, because I just think that's a good idea. In certain places like this, right here, that crucial pivot point, it's pretty much all walls, which I think is alright, should be pretty strong. And then for the bigger areas here, it obviously, there's walls around the cutout groove part. It's kind of hard to tell on layer view. And then this, the bulk of the track will be infill. So I think I'm going to do 5 walls, and then a 2 millimeter wall thickness, and then a 2 millimeter top and bottom thickness. One major question I want people's advice on is the bottom will be touching the ground and the top is only touching the tires. So I was thinking about maybe doing less top layers than bottom layers. It's not really a huge deal, but just something to think about. The bottom pattern I have right now is concentric, and the bottom initial layer, because I think that's a pretty strong one as opposed to going with lines. Which looks like this. Well, yeah, which looks like this. I'm not sure on that. Concentric kind of follows each feature and then works its way in. And to me, that looks pretty strong for a bottom piece touching the ground, but I'd love to hear somebody else's opinion. I also have alternate extra wall turned on. It says it results in extra prints and the infill gets caught in between walls. So you can see here, if you look, say right here in the region, if you go up a layer, there's an extra wall. Let's try and do this. Extra wall, extra wall, one less wall, one less wall extra, one less extra. So this infill part kind of gets caught in between. It only added, well, right now we're at 80 grams. If I turn it off, we're at 79 grams. So it adds 1 gram. If it says it's stronger, I think I'm just going to do that. Whatever. I've got infill set to 40%. So 60% of this will be air. That isn't walls. That seems like a good, well, kind of compromise point. Infill versus strength kind of seems like an exponential. Like 10 is not very strong. 40 is, well, say twice or 3 times as strong. But then once you get to 80, the distance or the strength increase from 80 to 40 doesn't seem to be that much. So 40 seems kind of like a sweet spot for density, as like strength as opposed to actual density without getting too heavy. Turning this down to 35, we only lose 2 grams. Turning it up to 45, we only gain 2 grams. So, I mean, well, here, if I go all the way up to 100%, we gain 23 grams. So, I could do it 100%, add 23 grams, but if there's 18 tracks, 23 grams is another pound. So it's already going to be pretty heavy. I'll do the well, you can do the calculations. I think 80 grams is where we want to stick at. Just not being too heavy while still being strong. So 40 I think is good. If you've got any other ideas, let me know. All these other settings aren't that important. Print speed is just what works for me. So yeah, I think that might have been it. If there's any other special features in Kira that lead to overall strength, be sure to let me know. I'm not an expert in, well, either of these programs. So yeah, that's pretty much the 3D slicer part. I'll just do some quick calculations here. Pretty much the whole reason I'm making this video is because these are going to be, well, it's going to take a while and it's going to cost, well, a moderate amount. So I want to make sure I get it right before I start. So I can print 3 of these at a time. I think 3 is the limit. So if we go back to this drawing, 18 per side, so we need 34. If we can print 3 at a time, probably could do this in my head, but it's going to take 11 batches plus an extra one. So right now my slicer says it's going to take 20 hours, 17 minutes. So let's just call it 21 hours maybe for heat up and whatever. 21 hours with 11 times. It's going to take 231 hours. So 9 and 5/8 non-stop days of printing. So it'll probably take me, well, if I don't want to print overnight, it's going to take probably 20 days at least, which is quite a bit. And if we need, okay, so 80 grams individually, and if we need 34, it's going to be 2.7 kilograms. Well, plus the nail weight, plus the rubber string weight, which I don't think will be much. So probably at least 3 kilograms of rotating mass, which will be quite a bit. My 6x6 already is a heavy unit, so I can just gear down. I think I have a DeWalt motor in there, which is pretty strong, but still, it's a lot of weight. It's gonna be 3 rolls of filament, and if they cost an average of $30, well, it's gonna be $90 plus taxes. So yeah, that's that's the project. That's my ideas on it. That's my thoughts. Oops. So yeah, that's kind of the design overview, the 3D printing overview, the calculations, the general thought process. Like I said, I'm just doing this video for feedback. If you've got anything you want to say, let me know in the comments. If you got some smart buddies, show them. I'll probably wait maybe a month before I actually start this. Let anybody who wants to get their opinion in. Yeah, I appreciate you taking the time. This is a pretty long video. If you made it all the way to the end, good for you. There's no reward here at the end, but thanks for watching. Okay, I lied. This isn't exactly the end of the video. Here we go. This will be up. These are the tracks. Well, the track versus the tire. It's almost snug. There's no real sideways slip when it's fully engaged. The sidewalls touch the sides. I mentioned about putting some more traction-y pieces on the bottom or a traction design. I didn't mention anything about putting a traction design in here. As you can see, there's alternating lugs. So I thought about putting, well, corresponding alternating lugs, but I'm not sure. You'd have to design those just right in order for the spacing to be, well, correct, I guess. It could be done. I still might do it. I'm not sure. Yeah, that was the last. I don't even know what to say about that. It was just the last thing I wanted to say. The tire, like if I push, it's pretty strong by itself because the sidewalls I think are gripping the side. So flat will probably do it, but it is just another thing to think about because you could have a piece here, piece here, piece here, piece here, you know, and it would be locked in for sure then.